Hello, everybody. This is a pre-recording of a lesson on pre-calculus inverse functions. So our warm-up was to match vocabulary with their definition. So if you missed class, are you catching up? That was something that we did in class. So here's our warm-up. We just did it. Our objective agenda: evaluating inverse trig, exploring domains. We'll do a brain break. We have a check for understanding for evaluating trig functions. We will explore composite functions a little bit, and then there will be an exit question. So if you're watching this asynchronously and you missed the CFU because you weren't in class, go ahead and send me an email. As usual, Wednesdays are our due dates for things. So homework 4 and formative 4 are due March 3rd. Homework 5 and formative 5 are due March 10th. So our materials: Nearpod, Zoom, side by side, capture sheet and modules, or take notes with pencil paper. There's a printable unit circle on the slides as well if you choose to use it. Interims are March 12th. Progress checks are March 24th, obviously not February 24th. And then please make sure that you are completing the homework. It is not going to be graded unless you complete it. Okay, so make sure you please try every problem. And going back to our objective today, we are going to be constructing the inverses of sine, cosine, tangent functions by restricting their domains. All right. So last class, we talked about inverse sine graph, inverse cosine graph, and inverse tangent graph. And basically how when you invert sine, cosine, and tangent, you don't end up with a function unless you do restrict the domain and range. So sine and cosine have a domain of -1 to 1. Tangent has a domain of -infinity to infinity. And then sine and tangent have ranges of -π/2 to π/2, and cosine has a range of 0 to pi. So you'll notice that for each of these three inverse functions, their domains last a full pi. -π/2 to π/2 is a full pi. 0 to pi is a full pi, and -π/2 to π/2 is a full pi. That's going to come back later. All right. So in order to grasp today's lesson, we really want to talk about how do we solve each of these functions or solve each of these equations. So what do we do to get our variable alone, right? So with x plus 5 equals 13, you all would know that we subtract 5. So we end up with x equals 8. For 7x equals 35, we divide by 7, and we end up with x equals 5. 2 to the x equals 24. We would take log base 2 of both sides and end up with x equals, we could say, log of 24 over log of 2, or we say log base 2 of 24. But either way, we are, in all of these three cases, we are taking the inverse operation. So we had x plus 5. So in order to move the 5 over and get x by itself, we had to subtract 5. We had 7 times x. In order to get the x alone, we had to divide by 7. We had 2 to the power of x. In order to get x alone, we have to take the log of both sides. Okay, well, what do we do when we have sine of theta? What do we do when we're trying to undo sine? We are going to use this notation, inverse sine. So in order to undo a sine function, we have to take the inverse operation. We have to find out what angle or radian measure will give you a sine of 1, right? Think about the unit circle again, and like I said, there's a principal unit circle that you can use in this module if you would like to kind of get your bearings and give yourself just a reminder of where all the points are on the unit circle. So where is sine 1? Well, sine is 1 where y is 1 on the unit circle. So that's going to be over here at 90 degrees, or pi/2. And some of you might remember that that does fall within the domain of sine. Remember, we talked about how the domain, or sorry, the range of inverse sine and the range of inverse tangent are the right half of the unit circle, right? From negative pi over 2 to positive pi over 2. So this does fit into that domain and range. Okay, so if you were answering in radians, you'd say it's pi over 2. If you're answering in degrees, you'd say it's 90 degrees. Okay, so inverse sine is a way of undoing sine, is a way of getting theta by itself. In terms of now solving equations, so now that we know that inverse sine is the operator that's going to get us back to theta, we're going to use that for solving these equations. And remember that inverse sine is, again, the range of inverse sine is the right half of the unit circle. So even though there are multiple points on the unit circle that have a sign of a given number, we're only going to use the parts of the circle that fall within our range and domain. And the purpose of that is, again, we talk about how a function needs to have a specific output for its inputs. So we can't say, oh, well, we input root 3 over 2 into the sine function and we get 2 answers. No, we can't do that. We need to get 1 answer, hence the restriction. Okay, so if you need to go into the slides and get the printable unit circle, feel free to pause the video and do that now. I'm going to go ahead and for these 6, I'm going to write out the inverse sine operation. We're not going to need to do that forever, but it's just a way of showing you what it is we're doing. Okay, so the sine of theta equals root 3 over 2. So if I take the inverse sine of both sides, I should get theta, right? So where on the unit circle is the sine of theta root 3 over 2? Well, it's up at 60 degrees, or you could say pi over 3. That's where, okay? It fits into that, that part of the unit circle that we are allowed to use for sine. Sine of 1/2, so sine of theta equals 1/2. So inverse sine of theta equals inverse sine of 1/2. So theta is going to be, well, where is the sine of theta 1/2? Right here at pi over 6 or 30 degrees. All right. Negative root 2 over 2, again, inverse sine of both sides. All right, so negative sine has to be over here. Root 2 over 2 will be at negative pi over 4 or negative 45 degrees. Okay. All right, I'll repeat the process over here on the right. So I have cosine of theta equals root 3 over 2, inverse cosine of cosine theta equals inverse cosine of root 3 over 2, which is going to be at pi over 6. I guess I should be consistent, put the theta there, pi over 6 or 30 degrees. Cosine of theta equals 1/2. All right, so inverse cosine of theta equals inverse cosine of 1/2. And that's going to be up at pi over 3 or 60 degrees. And then last but not least, inverse cosine of theta equals inverse cosine of negative root 2 over 2, which will be just like with sine of theta, it'll be at negative 45 degrees or negative pi over 4. Right. All right. All right, go ahead and pause this video and try these problems. Oh wait, I think I made a mistake on this last one. Yeah, I'm sorry, I did. So for this one, the very last one, I'm realizing that I was doing sine, inverse sine. So I'm sorry. So where you have negative cosine is negative root 2 over 2 would be over here. So that would be cosine, inverse cosine of cosine theta is inverse cosine of negative root 2 over 2. So that would be actually at 3 pi over 4. Theta equals 3 pi over 4 or 135 degrees. Sorry, that'll teach me to make videos this late at night. Because the top half of the circle is our cosine, allowed cosine area, and I accidentally did sine for this last part. So make sure that you correct your notes if you were taking notes along with me. Okay, so go ahead and give this a try. You can do your answers in radians and degrees. It's a good idea to do that for now, just to get practice at understanding that they're both related. So go ahead and pause the video and give these problems a try. All right, so I'm assuming that you've given everything a try. This is the, these are the results. And then I did the same thing with cosine over here. So let's fix this. So cosine of theta is negative root 3 over 2. That means that I'm living over here at 5 pi over 6 or 150 degrees. Right here for this other one, for inverse cosine of negative 1/2, that'll be at 2 pi over 3 or 120 degrees. And then this is okay. And then these are okay. All right. So go ahead and take a look at that. Make sure you have what I have. And now is a point of class where we would have a little brain break. This is a check for understanding, so you can email me your answers to this if you're watching this and you missed class. Okay, so now we're going to get into compositions a little bit. So that's when you actually have to do one operation and then take that operation to do another operation. So we'll talk about that. So arc sine is just the same thing as inverse sine. We've kind of talked about that. It's just another way to write inverse sine. So you have to take the tangent of arc sine of root 3 over 2. Well, you know about composition of functions, right? You take care of the inside function first, and then you apply the outside operation to whatever your result is from the inside function. So tangent of arc sine of root 3 over 2. Well, what's arc sine or inverse sine of root 3 over 2, right? We don't have our unit circle on this page, but that's okay. We understand that the angle or radian measure that has a sine of root 3 over 2 is 60 degrees. So this would be tan of pi over 3 or tan of 60 degrees, right? And now we know that the tangent of pi over 3, tangent of 60 degrees, is root 3 over 2 divided by 1/2, or just root 3. Right, so we could write it all out if you're not comfortable doing it sort of more automatically, but it's root 3 over 1 or root 3. And eventually this will be very automatic for you because we're going to practice this a lot. Okay. The second composition is one that is not on the unit circle. It's actually, you have to think about triangles, right? So tangent of inverse sine of 5 over 13. So 5 over 13 is your clue that this is not a special triangle. We're going to actually have to draw this triangle. So I'm going to make it in the first quadrant, because if it has a positive sign, it has to be in the first quadrant, because inverse sine is only happening for us in quadrants 1 and 4, right? And sine is y, so our y value has to be 5. Our hypotenuse has to be 13 because, right, sine is y over hypotenuse. And then we have to find our cosine, right? I'm going to say this triangle is not to scale because it's not. So if we apply the Pythagorean theorem, right, 5 squared plus x squared equals 13 squared, we'll get that x is equal to 12, right? So if our triangle looks like this, we can find our tangent by just applying that trig ratio. Tangent of this angle theta has to be 5/12. And that's it. All right, so we can try a couple more. Sine arc sine of 1/2. That's going to take you back to 1/2, right? Arc sine of 1/2 would be pi over 6. Sine of pi over 6 would be, again, 1/2. So this is actually a function, an inverse function of itself, taking you back to the original, right? Cosine of arc sine of 1/2. Arc sine of 1/2 again is pi over 6. Cosine of pi over 6 is √3/2. Cosine of arc cosine of √3/2. That again should be √3/2, because if you're taking your own function and reversing it, you should be going back to √3/2. And then tangent of arc sine of √3/2. So arc sine of √3/2 should be pi over 3, or 60 degrees. So that's tan of pi over 3 or tan of 60. So again, that's √3. Okay. All right, so I hope that this video explained things for you and helped you understand how to evaluate inverse trig functions with that restricted domain. Thank you so much for watching. As always, just contact me if you have any questions, and we'll see you next time.